So we just saw the default bridge network with the network ID 172.17.0.1. So all containers associated to this default network will be able to communicate to each other. But what if we wish to isolate the containers within the Docker host? For example, the first two web containers on internal network 172 and the second two containers on a different internal network, like 182. By default, Docker only creates one internal bridge network. We could create our own internal network using the command docker network create and specify the driver, which is bridge in this case, and the subnet for that network followed by the custom isolated network name. Run the docker network ls command to list all networks. So how do we see the network settings and the IP address assigned to an existing container? Run the docker inspect command with the ID or name of the container, and you will find a section on network settings. There, you can see the type of network the container is attached to, its internal IP address, MAC address, and other settings. Containers can reach each other using their names. For example, in this case, I have a web server and a MySQL database container running on the same node. How can I get my web server to access the database on the database container? One thing I could do is to use the internal IP address assigned to the MySQL container, which in this case is 172.17.0.3. But that is not very ideal because it is not guaranteed that the container will get the same IP when the system reboots. The right way to do it is to use the container name. All containers in a Docker host can resolve each other with the name of the container. Docker has a built-in DNS server that helps the containers to resolve each other using the container name. Note that the built-in DNS server always runs at address 127.0.0.11. So how does Docker implement networking? What's the technology behind it? Like, how are the containers isolated within the host? Docker uses network namespaces that creates a separate namespace for each container. It then uses virtual Ethernet pairs to connect containers together. Well, that's all we can talk about it for now. More about these are advanced concepts that we discuss in the advanced course on Docker on CodeCloud. That's all for now. From this lecture on networking, head over to the practice test and practice working with networking in Docker. I will see you in the next lecture. Hello and welcome to this lecture, and we are learning advanced Docker concepts. In this lecture, we're going to talk about Docker storage drivers and file systems. We're going to see where and how Docker stores data and how it manages file systems of the containers. Let us start with how Docker stores data on the local file system. When you install Docker on a system, it creates this folder structure at var lib docker. You have multiple folders under it called AUFS, containers, image, volumes, etc. This is where Docker stores all its data by default. When I say data, I mean files related to images and containers running on the Docker host. For example, all files related to containers are stored under the containers folder, and the files related to images are stored under the image folder. Any volumes created by the Docker containers are created under the volumes folder. Well, don't worry about that for now. We will come back to that in a bit. For now, let's just understand where Docker stores its files and in what format. So how exactly does Docker store the files of an image and a container? To understand that, we need to understand Docker's layered architecture. Let's quickly recap something we learned. When Docker builds images, it builds these in a layered architecture. Each line of instruction in the Docker file creates a new layer in the Docker image with just the changes from the previous layer. For example, the first layer is a base Ubuntu operating system followed by the second instruction that creates a second layer which installs all the apt packages, and then the third instruction creates a third layer with the Python packages, followed by the fourth layer that copies the source code over, and then finally the fifth layer that updates the entry point of the image.